Yeah. All right. So I'm live streaming right now, and there's a bit of a delay usually. Let's see.
I'm seeing the stream. I'm seeing the
Uh,
stream.
are you seeing the stream? All right. So live stream. Okay, I see the stream too. I
Yeah,
have
and
to
by the
mute
way, as a
myself.
side, please add me to the group. I got the live stream. I got the live stream.
Is the audio on, Arthur?
The audio is on.
All right. Cool. All right. I'm gonna pause it. I'm gonna stop streaming and cool.
I'm also posting the link on our group right now.
Thank you. All right, guys. I think we're live streaming today. We are very much looking forward to talking to Sumit from IBM, Sumit Gupta. And Sumit has been generous enough to come spend a little bit of time, talk about his views and obviously his background in AI, but more importantly, what IBM is doing, how IBM kind of looks at the world. I think it'll be really interesting. I think um, IBM being IBM, I think is such a force, all the way from Watson to some of the interesting things that they're doing now. So we're really looking forward to it. So with that, let's kick it off. Sumit, let's start maybe with introduction. Your background and then your role within IBM.
Great, thanks, Mike, and then thank you for having me on this live stream. So I'm at IBM right now. I'm in the Cognitive Systems Business Unit, and I run the product line for machine learning, deep learning, and I also have the HPC, the high performance computing products. But we have a very big, and maybe we'll touch upon this in a little while, but we see these two markets sort of converging, right? The traditional high performance computing and where deep learning is going. My background, right? So I've been at IBM 2 years now. Before that, I used to be the general manager for the NVIDIA GPU computing group, right? So I was there for 8 years. I helped build that business from the ground up. You guys know that that's become sort of the engine for deep learning now, right? GPUs have become the engine for deep learning. All of that developer outreach, how we got there, that in itself is a remarkable story. I have a background before that. I used to be at another startup. I was at a VC for a while. I was an entrepreneur in residence. I have a PhD in computer science and an undergraduate in electrical engineering.
That's really cool. Yeah, sounds like you have, in addition to IBM background, I mean, your background has been deep in, CS, AI, and your time at NVIDIA is, you've seen what came before and what made all this wave possible. Maybe the other way to go on to the next one is, I think everyone is sort of very excited to kind of hear about based on your role within IBM, what are some of the areas that IBM within the sub areas within AI that IBM is spending time on, and sort of your role within that?
Yeah, so for IBM, obviously the whole cognitive space, right, and AI as a piece of cognitive is central to our company, right? And so it manifests itself in many different products and many different business units. Pretty much every business at IBM is either a user or providing products around cognitive solutions. So obviously we have Watson, which is our platform for cognitive computing. And what that means is Watson provides a set of, first of all, solutions, right? So we have things like that for the radiology solution, but we also have a Watson developer platform, which is really a set of APIs. So for example, my favorite one is if you have a mobile application, there's absolutely no reason for you to go develop a voice API for your mobile app. Just use a voice API. Watson has an excellent one. There's a few more competing ones out there. But these platforms provide, essentially some of the most common services.
Yeah.
Vision API, personality trait APIs, sentiment analysis APIs. So Watson provides those APIs to developers to build their own applications. Then there's many other parts to Watson, right? We obviously also have the data services, the data platform, We have developer tools that we're building. So there's really, it's becoming a very big platform. What I've been focusing on is sort of the open source market or open source community, right? What we've done is we've taken the open source machine learning, deep learning frameworks like TensorFlow, like Caffe, like Torch, and we've created an enterprise distribution. So just, what the insight we had was we work a lot with enterprise customers, right? All the big banks, retailers, logistics companies. You go to these guys and they say, hey, we love trying TensorFlow or Caffe. The challenge is in many companies, they're not allowed to download open source code from GitHub, right? I mean, they do it unofficially, but if IT finds out, they get locked out. And in general, I don't know if any of you have, I'm sure you have, right, downloaded TensorFlow or Caffe and tried to build it. Every time there's a new version, like there's 100 packages that these software depend on. Just building the software takes time. So in a sense, what we've done is we've tried to ease that first process step, right? Just like you don't go get Linux from linux.org, you go to Red Hat, SUSE, Canonical. We've become the Red Hat of deep learning. We've created an enterprise distribution. We call it Power AI. We take the latest version of TensorFlow, latest version of Caffe, Torch, Chainer, you name it, right? Theano, and the underneath packages and libraries. And we give you a single binary distribution. You install that binary, you got the entire caboodle of deep learning software installed, right? And so that's like step one. And as we talk more, I'll tell you about where we're going with this roadmap.
Wow, so that's really interesting. So thanks for sharing that. I mean, one interesting observation is that for I think a lot of folks here they don't. Yeah. So what you mentioned about being able to go to GitHub and download just some open source code and start using it, that is, I think, for people working in Fortune 1000, Fortune 5000, or Fortune 500, it's a foreign thing, right? I think for a lot of other developers who work in smaller companies, of course you do it. So this is actually really interesting to hear. You guys are helping package and make it kosher in some ways for larger enterprises to use it. Let me ask you this.
What we find is not just larger, right? So, so this was the starting value, right? There's actually no reason why you or anyone on this call should be building these packages by yourself.
Yeah.
We distribute this software for free, right? The binary packaging itself is free because we took open source code, we just packaged it, we curated it, tested it, packaged it. Now, we have the same model that a lot of open source companies do, which is if you want support, you have to pay for the enterprise support. If you want services, you have to pay. And we're building enhanced tools on top of it. We have developer productivity tools. We have integration with Spark, right? A lot of people are trying to distribute this with Spark. We have a distributed TensorFlow that we're working on, which is distributed using MPI. That's where that's where we start charging for the value-added stuff. So again, very much a classic software, open source software model, right? Cloudera, Hortonworks, you name it. Every company in the world has sort of built this model. And we've taken the same model around deep learning to produce an enterprise software there as well.
That's interesting. Go ahead, Arthur.
I'm sorry. Just a quick question here for Sumit. On different type of packages, do you see which package is more promising? So like in deep learning framework, do you prefer, say, more on TensorFlow or more on Theano? Which one do your group prefer to develop more?
It's a very good question. You talk to 5 developers, they'll give you 5 answers. Right? And I'll tell you, a lot of it has to come to heritage, right? If you went to University of Toronto, you went to Stanford, right? Or you went to one of the whichever college you went to, right? Often, because a lot of the people who are using these are recent graduates from academia. And in enterprise, what we're seeing is, in fact, just like it happened in the early days when it happened with Linux and everything, you'll see all kinds of different packages out there. right? Now, we are seeing more and more enterprises using TensorFlow. I have to tell you that there is a pretty big adoption, and you see that even in the GitHub, like contributions to TensorFlow are the highest right now, right? So you're beginning to see TensorFlow sort of becoming a much more popular framework. But we are agnostic in many ways, right? Because we're just, again, as a software distributor, we're giving the data scientists whatever they want, right? But we are doing a lot of innovation ourselves around TensorFlow, because again, because of a lot of our enterprise customers are using that, we get a lot of requests to for example, enhance the distribution of TensorFlow. Just yesterday or 2 days ago, we had a pretty successful webinar with the Google TensorFlow guys. So Rajat was on the call, Rajat Monga was there on the webinar. And pretty large number of people attended that as well. So I encourage this audience to go check out the recording of that webinar, which just happened a few days ago.
Yeah, and by the way, Sumit, just so that you can email us the links to all this stuff that you reference, and we will repost it once we're done with the live stream with the video into our group, so people can check things out.
Okay.
And so that would be great. I think people will be really excited to try some of the stuff out. Now you had mentioned some of the companies that's starting to use TensorFlow and test it out. I think one of the big questions have always been, what is the state of larger companies, larger enterprises, let's call it the Fortune 1000, 2000, right? The traditional IBM customers. What do you think? What are the state of awareness and adoption or trialing with the TensorFlows and sort of like some of the deep learning stuff of the world? Are they still in the labs, if at all?
Yeah, I would say, shucks, I don't want to throw someone under the bus, but in most customers that I'm talking to right now, they are not necessarily in production with deep learning, right? So what's happening is most large, let's say banks, let's take banks as an example, right? Most large banks have been using machine learning, clustering algorithms, all that stuff for a while now. They have fraud analysis, they have credit risk analysis, they have a lot of sort of traditional machine learning algorithms there. So they have that expertise of people who understand machine learning. Those are the folks who typically are now looking at deep learning and where it makes sense, augmenting their work with deep learning or improving their earlier results with deep learning, right? And finally, by the way, it all comes down to data, right? You need enough tagged, sort of good quality data and to be able to really train a good deep learning model, right? To be able to beat these traditional machine learning models. But that's really where we're seeing I would say the inroads into AI in the enterprise is typically when they already have a machine learning group. Having said that, many companies have sort of seen all the press, all the hype around AI, and have started hiring many more data scientists. And in many cases, they start, most companies have not done the simple stuff. They haven't done the R statistical packages, the Python. So many people are just starting there, right? And that's why you in fact see Keras is becoming such a popular platform, right? It makes it easier to use deep learning, and it makes it more familiar to a lot of people.
Yeah.
On the companies that perhaps Sumit you work with, do you see like whether there are some dominating segments that deep learning is being more used these days than say 5 years ago? Or do you also see some kind of emerging segments that that is so surprising that segments are actually using more machine learning and deep learning than before?
I don't know if I get surprised anymore because the use cases are so broad. So not yesterday. Yesterday I was in New York meeting a couple of our banking clients. The day before that, I was at we had our advisory board there. So our top clients, some of our top clients were there, and it was a completely diverse group, right? We had retail clients, we had some of the rental car companies, we had a furniture company, a pretty big furniture store company in the Southwest. Of course, the banking community was represented. There was a pharmaceutical companies, very broad set, and pretty much everyone has an AI project, right? fact, the joke I say or the statement I make these days is, you know, maybe about 10 years ago or 8 years ago, every CEO leaned over to his CIO or her CIO or LCTO and said, we really got to go figure out big data. About 5 years ago, they leaned into them and said, we really got to go figure out cloud. Pretty much in the last 12 months, every CEO has leaned over to their key staff and said, we got to go figure out AI. Right? Because I think
Best statement. Best.
right, and I'll repeat something that Andrew Ng says. Right, Andrew Ng is very popular in saying that AI is the new electricity. Right, I'm sure you've heard them say this, and the point he's trying to make is electricity changed every industry. It completely fundamentally changed every industry, and that's the point he's trying to make, that AI is going to fundamentally change everything we do. I'll give you a few examples. Right, IBM is using, as I said, we're both a producer and a user. We're trying to eat our own dog food, right? And for example, we have started migrating a lot of, not migrating, but we started using chatbots for our help desk, right? And sure enough, the customer satisfaction is up, the accuracy of answers is up, in fact, the understanding, these chatbots understand language better than some of the voice operators we had, right? Clarity of communication, both ways, because you're listening and you're also speaking, right? So that communication has improved. We've been using some of this Watson stuff for ad buys for our marketing, right? Smarter ad buys. We've been using it for our customer support, right? So we have our own help desk, but we have actually one of the world's best customer support organizations, right? For all the products we produce, uniformly ranked as one of the best in the IT industry. And they've started experimenting with a lot of AI methods to provide the support to their customers. And the list kind of goes on, right? I mean, we have like 10, 15 of, I think we have 35 pilots right now. I forget the exact number, but it's a large number of pilots inside the company. Everything from support, internal support, to external support, to kind of marketing and security, cybersecurity, all over the place, right? Intelligent video analytics. So there's a lot of use cases, and with customers too, right? You talk to the banks and pretty much the stuff you would expect: fraud detection, credit risk analysis, customer churn, upsell, right? Pretty much the things you expect. Talk to a retailer, recommendation engines, logistics planning, right? Inventory planning, route planning, right? If you're a very big corporation and you want to do route planning for all the inventory that's moving around, right? The trucks, the actual people. You talk to, I had a really interesting use case with a utilities company. They have to inspect these high power transmission lines, which are pretty high up, right? They're literally physically very high up. And earlier they used to send people up. Now they're using drones. Now, once you have a drone up there, gosh, should we do that analysis of the video by a human or just automate that process, right? So because you can churn through so much more data, right? I mean, if we can move to a dashboard-based system where the video analytics system is actually signaling, hey, look at time frame 33 seconds to 45 seconds, right? I think there's something there. Yeah. Rather than go look through 82 hours of video and try to figure out if there's something missing. You have a lot of fatigue from people who are actually looking at these videos, right?
Yeah.
So the use cases are very broad. I mean, it's just amazing how every company is trying to reimagine their business processes, their use cases.
Yeah. And Sumit, so in this, how do you see where the bottleneck is today, to actualize some of this stuff? Do you think it's talent? Do you think it's labeled data, training data? Do you think it's an easy ability for the machine learning in-house folks to start doing experiments, start building stuff? Yeah, where do you see the bottlenecks are like today?
Yeah, so I think, I want to say that there are really three problems. Maybe I'll bucket a lot of things in my three buckets, right? I think the first bucket is sort of just ETL,
Hmm.
taking all of this data and massaging it, prepping it. I was with a customer yesterday who said, if you solve my ETL problem, I'll buy anything you sell me. Right? He says 80% of the time, he was emphasizing a point, right? The point though was 80% of their time they're just trying to get all this data to play nice, to
Yeah.
massage it. Right? I mean, I had a customer who told me, a retail customer, he says, to use Cafe, every image has to be resized into a particular format. And on my, all the inventory of images we have, gosh, that's a tough problem because you not only have to resize it, you now have to validate, did I do that accurately? Right? Was there loss of, did it by mistake crop something? Right? So you have to remember in a real production environment, there's a lot of data integrity, data checking, validation that you aren't, and you guys know this, right? I'm kind of preaching to the choir here, but just prepping the data. So data ETL, data prep, actually is a huge pain point in this industry.
Hmm.
I would say a lot of people who get into deep learning sort of use the standard data sets that come with these frameworks or that are open source. But there were people who probably spend months creating that data set for you,
Yeah.
right? Why has it taken so long for these companies to release these data sets, right? Because it took them a long time to prep them and make them ready for machine learning or deep learning.
Yeah.
So ETL is one problem. The second problem, associated but different, is actually data scientist developer productivity, right? So again, um, there are the ninjas. I think you were kind of describing this, Vaikit, as you were telling me more about the group. There are the ninjas in this space, right? Who are deeply invested. They understand it inside out. They in fact understand the algorithms. But let's take the 80-20 rule, right? 80% of the people in the long term, or even today in AI, are not going to necessarily get very deep into what the deep learning algorithms are. They just want to use a method, right? They would like to have a GUI where they just say, okay, try method ABC, right, and see what happens, and be able to do a lot of this analysis, right? So in fact, we're building a lot of tools. So for ETL, we've been building a tool for kind of with Spark, right, using Apache Spark for ETL, which is what a lot of our customers are doing. But we're trying to automate that process for them.
Hmm.
For this data science developer productivity, we have many tools from IBM. One of the simplest ones is we have a Jupyter notebook-based tool called the Data Science Experience. And then we're building another tool specifically for deep learning. It's in private beta with some customers right now, which essentially monitors how the training is going. It manages your data sets. It tells you what you've already run. We see this problem. People are like, did I run that data set yet or not?
Hmm.
I mean, just once you have a lot of data sets, a lot of models, you got to make sure you're kind of continuously progressing in your learning. It also, this tool also uses Spark underneath it. And what it does is it ends up launching, for example, 10, 20, 30 Spark jobs to go search the hyperparameter space. So it'll just search all different types of hyperparameters. It'll prune off the bad ones and sort of try to give you a suggestion that here are the good parameters, right? So anyway, so we talked about two problems, ETL, developer productivity. And then the third problem, once you're actually doing this work, is performance.
Hmm.
Despite the fact that we all are using GPU-based hardware, it still takes days, sometimes weeks, to train a model, right? Once you have real large data sets. And we're spending a lot of time there. In fact, there we've made an investment both in the hardware and in the software. We've built a server, we call it the Minsky server affectionately.
The Minsky server.
Is the father of AI.
Yeah.
But we built a server with NVIDIA where we embedded a special interface called NVLink, right, which is a high-speed sort of interface between the NVIDIA GPU and the power processor. So, this is part of our open power initiative. And, so we have a hardware platform which gives you node-level performance. And then we're doing distributed computing using MPI and Spark to be able to scale out to multiple servers, tens and hundreds of servers, to bring down that weeks to hours of training time, right? So that's kind of our strategy, right? ETL, developer experience, performance.
That's really cool. Thanks so much for delineating it. I don't think, yeah, I think that's a very articulate way to bucketize, what are some of the areas that I feel like blocking the democratization, let's call it that, of AI, right? I feel like a lot of them are not so much the algorithms or the actual science itself, but a lot of it it's around getting to that, right? It takes a long time to set up the packages, to get the configs and the environment correct. Some people just lose hope, halfway through, and the performance and the sort of talent productivity. Those are some really real things, and I think that once those floodgates get lifted, right? By the IBMs of the world and others, we're gonna see like a lot of parallel processing, a lot of talent processing at the same time. I think that's gonna be some really interesting stuff. Sumit, you talked a little bit about performance and also given your background from NVIDIA. We've seen a lot of investments and some exits in the semiconductor, sort of custom ASICs to AI, if you will, space. What are your thoughts just in terms of you think, NVIDIA will continue to dominate, or you think that there's room for some other pure plays that are, custom built DL chips to come in and maybe take some share? Thoughts?
So I think in the AI space, from a hardware perspective, we are in the 8086 world right now. We're in the early days of hardware innovation, right? Now, who wins out in the long term is obviously, I don't have that crystal ball,
Mm-hmm.
but clearly NVIDIA is not only a leader, but is making big investments both in the chip and the hardware and the software, right? So they do have a very nice, I would say, investment and real value that they bring to all of us, right? There are a lot of other startups out there. There's big companies trying to do this. I think it really does depend on, it's hard for me to predict where this will go. But I think there's a lot of room for innovation, not just in the hardware, but in the software. And the key is going to be co-design, right? Even when I talked about performance, I said, look, I can do stuff in the node at the server level. But then if I really want to get weeks down to days or hours, I need to do more software work. I need to go do clustering. I need to do distributed computing. And so I think the key is going to come down to a hardware software co-design at the chip level, at the server level, at the cluster level. This is not going to be a simple answer. Also, I think our conversation has been very focused around training right now, right? Building these models, training these models. Once you move to production or inference or classification,
Mm-hmm.
I think that's another very fascinating and, I think a lot of room for growth, right?
Yeah.
There's just so much going on there, right? The traditional companies that have sort of focused on the embedded space have obviously added or are adding deep learning neural network support, right? We're seeing that happen. But the interesting thing is what's happening at the platform level. Again, the chip is interesting, but you got to build platforms, you got to build edge computers, right? IBM actually has a very interesting IoT end-to-end, I would say, platform and consortium that we call the Blue Horizon,
Mm.
right? And there we're really trying to solve some of these problems from taking the training and taking it down to production for an IoT level. So, and we're doing it use case by use case, right? I mean, or I would say we're formulating our strategy or evolving our strategy by taking specific use cases. Because an edge computer could be your phone, or it could be the base station of the cellular provider, or it could be the gaming console in your house. So there's so many things that could be an edge computer. It's not a clearly defined thing. My laptop could be an edge computer, right? And depending on the computing capability that you have on each one of these platforms, you're probably going to provide a different level of service to your customer.
Yeah.
Um,
Yeah. Go ahead.
on the training front, for Sumit, how do you feel about the current trend that people try to implement, like a like a deep learning processor using FPGA, do you see better results in-house within IBM, or do you think that that will be or do you feel that a GPU will still be this general purpose processor for deep learning?
I mean, that's a hard question for me to answer, to be honest. I've seen more around FPGAs from a inference perspective, not training. Right? Personally, that's where I've seen people, I would say, kick the tires or try FPGAs. Um, but in reality, the jury is still out on inference, right? Because not many people are in large scale inference or in production with deep learning. A lot of people are just using CPUs, right, for production. And like we just talked about, the end client for production can sometimes be your cell phone.
Yeah.
So, this it's not clear to me where the accelerator for inference is going to fall. There's again, in my opinion, lots of room for innovation. Right, NVIDIA is innovating there. They have GPUs specifically for inference. Clearly, the FPGA guys are trying something there. There's lots of ASIC companies, right? Chip companies that are trying to build ASICs for inference as well. So there's, in fact, IBM has had some research projects around that, right? We announced this research chip called True North, which is an extremely low power chip for inference, right? So there, the metric was to, I'll make up a hypothetical, right? In 0 watts, how much inference can you do? If you start with that mentality and now you start adding milliwatts to it, how much more inference can you do, right?
That makes sense.
So we're seeing a lot. Again, it's the 8086 world. It's a wild west. There's so much opportunity for all of us to innovate right now. And there's a lot of companies, huge market opportunity. AI is going to be the computing thing for the next 10, maybe 20, maybe 30 years, right? It's hard to even predict. It'll become the norm, is probably the best way to say it, right? So there's so much room for innovation here.
So now you talk about it in a way. The work such as tensor processing unit does look like a work which is suitable for scenarios for Google, but for a majority of us, it's more likely that we want to put deep learning into like an embedded device, an IoT device. That seems to be more a real life scenario. So that's what I think. That's how I would summarize your point.
It depends completely on the use case. So if I'm building a recommendation engine for a website, right, it's going to run on a server, right, and it'll be served off as a microservice. It'll seem like it's on your mobile phone, but it's really a microservice running on a server somewhere. If you're building a image recognition thing for your mobile app, more than likely you want to do most of the inference on the mobile phone, right? If you're in a car, right, you can't expect the car to be always connected to the cloud. So you got to do a lot of the inference in the car. So, depending on the platform, right, in many cases, the platform may not, a lot of IoT platforms, industrial and consumer IoT, are not going to be always connected. So you need to be able to do inference on the endpoint. So it completely depends on the actual service, workload, use case that you're building. So it's not a simple answer is my point to you, right? It really depends on the applications.
Very true, very true. Yes.
Switching topics a little bit, we've got a few questions that have just been asked. They kind of all fall into the category of, hey, AI is the next big thing for the next, decades or a few decades. We are beginners. We like to get into it, either as a either I'm a student right now or I'm a professional out there working. Sumit, what do you see just in terms of, at IBM, when IBM sort of evaluates deep learning talent to bring in as a researcher or as a developer, in terms of, the bar they look for, right? From a coding capability, from a, math and calculus and understanding of both of those. I think people are sort of interested to kind of hear at what level of proficiency they ought to be competitive in some of these positions.
Right. So it's again, when you ask me those questions, I immediately in my mind have a stack diagram, right? And the stack diagram is, or a layered cake diagram, right? The layered cake is, there's a layer which is the data layer, right? So you're storing your data somewhere. It might be a database, MongoDB, even Oracle, whatever where your data is actually stored. Or it may be a data lake like Hadoop. A lot of people are using Hadoop naturally here, right? On top of that is the framework itself, whether it's a machine learning framework or a deep learning framework. So if you're a developer in the data lake, or and by the way, we need people there too, right? Or you're a developer who builds a framework, right? It's a very different requirement. Now you have users. You go right above the machine learning framework, and you have someone who's actually building a neural network model, training the model. Then above that, you have a person who takes existing models and maybe tweaks them or trains them with new data, changes the hyperparameter, small. So at each level, the kind of requirements we have is different. I would say the person who's tweaking models, changing models, right, to some extent, they're what we've been calling the data scientists so far, right? They usually have been using R packages, Python packages. Now they can use a deep learning package. Right? And with Keras and everything else, it becomes easier and easier for them to use it. One click down, you have people who are building models. They're trying to build the next Inception V3 or the Alex there. For that, you need a pretty good understanding of how deep learning works. You need to be able to understand how the various layers are formed. You need to be reasonably, I would say, computer science savvy at that point, right? Pretty savvy. And then you come into the framework, right? Building these frameworks, enhancing the algorithms of these frameworks. Now, very few people are actually doing that work, right? It's in the big companies, or it's in the research community,
Yeah.
and that's typically PhD level computer science, very very deeply technical people who are really understand the algorithms of deep learning, right? So, and we hear, by the way, a lot from the people building the frameworks, right? You'll hear a lot on publications, and Google and Facebook and Microsoft and IBM and many other companies publish a lot there. And you also hear a lot of noise from the people who are building models. Every time there's a new, Inception V3 and Calyx there,
Yeah.
breakthroughs, right? But in reality, the mass is on top. It's going to be the data scientist who is going to use these models, tweak them, change them. That's when AI becomes, I would say, everywhere.
Yeah.
Right? That's when it becomes a utility for all of us to be able to use for our problem, right?
Yeah. Yeah. So I think right. So I think to paraphrase you, right? I think if you are, for our audience who are looking to who may just be beginner or looking or intermediate and looking to kind of be that layer in that development layer, not so much researcher, right? I think the ability to take the existing frameworks and tweak it and keep up to date on what are sort of the latest and greatest, and have the context around that. I think that's important. I think those are sort of on point. I think if you want to be a researcher at that the core layer, the PhD layers, I think the bar is much higher, where you absolutely need to know all the deep math, all the deep algorithms, and the like.
And by the way, we are recruiting in every one of these stacks, right? We work on every one of them, and and you're absolutely right, right? So I'll tell you that one of the things we see in the community is that obviously there are not enough data scientists out there who are trained. Forget about deep learning, but just to use machine learning and analytics. Right? So we are doing a lot on education there. We've actually set up our own developer education group inside IBM to go educate specifically data scientists. We're partnering with companies like Galvanize. Galvanize is a company that actually has centers around the world, and they do 3 month, 6 month data science courses. Like, these are full-time courses. You go there, you go every day to school, and you learn data science. And they give you realistic problems. They partner with us. They use Watson, they use R, they use Python. So they show you what's out there and how you can use it. Then we are also working with NVIDIA. NVIDIA is doing at the Deep Learning Institute, right? They've been doing a bunch of stuff to teach people how to use deep learning packages. But building the actual frameworks, the PhD level stuff, it's really coming out of either academia or people who've graduated from academia into one of these larger companies where they're doing fundamental deep learning algorithm research.
Yeah, yeah, that's no, I think education is a huge piece. I'm actually I didn't realize that you guys were doing a lot there just to disseminate. I think which is great. I think it's we hear this every day in our group in our forum, and we've kind of to summarize a lot of the new changes. We keep on updating we have a top 15, we have a FAQ list essentially, right? If you're a beginner, here's where you go to take the online
Right.
classes. These are the books you ought to read. We kind of try to structure it for you, and we find that it's very well received because I think it moves so fast and it's fairly unstructured.
Oh,
I think
absolutely, absolutely. And obviously the MOOC courses, Udacity, Coursera have become very popular. There's a lot of courses online that you can take, right? There's a lot of self-learning things, but what we're finding is that there's also a lot of people who are saying, you know what, I'm just going to retrain myself,
yeah,
and I want to go to a structured program, and that's where Galvanize comes in, and
yeah.
our partnership with Galvanize comes in, right? In fact, if I'm not mistaken, yeah, this coming weekend we have a kind of a hackathon at the Galvanize in San Francisco.
Oh, cool.
So if anyone here is listening in is from San Francisco, check out Galvanize's website. IBM and Galvanize is doing what we're calling the Cognitive Builder Fair, right? It's basically Friday night, Saturday, and Sunday. So we'll do a little bit of lecture, which is mostly around here are the things you can do, here are the tools available, and then we'll run a hackathon around it, right?
That's awesome. Yeah, Sumit, I'll follow up with you with all these relevant links because I think, yeah, absolutely, guys would be very interested in checking it out for stuff like this.
Cool.
On the point about education, about deep learning education within IBM, so as you know, that all the big houses, uh, like Microsoft, they have their own cognitive toolkit, and Google would have TensorFlow, and Amazon support MXNet. But on the other hand, IBM seems to, from what you described, is more agnostic about the framework. So when you start this kind of education program, what will be your choice of toolkits to teach to developers, and how do you uh, bring them into familiarity with different types of toolkits?
Right.
So in a way, it is a very interesting proposition. So I wonder what is the positions of IBM on it?
Yeah, so we typically, first of all, obviously, our first message to most people is if there is an existing API, please don't rebuild it, right? If you want to use voice, you know what? It's very hard for most companies, most enterprises out there to go beat IBM or Google or someone else who has just so much. IBM has had a voice team for more than 30 years, right? And of course they started using deep learning several years ago, but just why build something where you have something where world class, maybe number one, maybe number two, right, in the top three, and within a percentage of each other, by the way, right? All of us are pretty close to each other right now in terms of quality. So if you want to use a good vision API, a good voice API, we have there's a whole bunch of APIs we have, right? Sentiment analysis, like we in fact bought a company called Alchemy, which whose whole business model was APIs, cognitive APIs, and we integrate that into Watson. So our first thing is, hey, use APIs where possible. Now, where you want to build a bespoke thing for your own solution, you're building a recommendation engine, here are the tools available. We typically show one or two different things, right? We typically will show them Cafe and TensorFlow. There's again, because you're teaching, you try to use simple things. Use existing well-known benchmarks, well-known models, and really are focused more on how to actually get your data ready. How do you actually use the tool? What are the parameters you have that you can change? What affects accuracy? What affects training time? So that's really where the focus of a lot of this stuff is, which is what the focus in real life is going to be, right? Which is where you're really going to spend a lot of your time.
Yeah, no, that's interesting. That's great insight. We have a few minutes left. I think we are good with some of with the question. We've covered a lot of ground, which I think is really interesting. Maybe
That's
to start to wrap, Sumit. I mean, this has just been great, right? I think this is I think the way you've kind of structured your thinking, I think is relevant from helping the folks in our group to think about, where do they spend the next 6 months? How do they think about areas to kind of build on? And there's a bunch of startup guys too who are kind of looking at, what are the problem areas that they want to innovate on. So this is really good. Maybe to wrap, any other areas that you think it's sort of hot on your mind that you'd like to, sort of say a final comment on?
Yeah, so you mentioned startups. Actually, I spend a lot of my time. I live in Silicon Valley. I spend a lot of my time working with and talking to startups. One of the things I'll tell you is when I go talk to customers, right? Just like I said, if there is an API, why build it? Most customers are telling us, I don't necessarily want to build these solutions myself. If you have a solution that's already built, or you have a partner, a startup, or a software company that's built something, I'm more than happy to use things, right? And so I'm always looking for startups that have an enterprise solution because I have the route to market, right? These are our customers. We talk to them all the time. We have the ability to go partner with startups, take them to a customer, and present a complete solution,
Hmm.
right? So we're always looking for these kind of solutions. And obviously, IBM builds a lot of them ourselves, right? We have a very big solutions team. We have a very big services team. We keep building new solutions, but we're always also looking to build an ecosystem of startups and partners that we can
Yeah.
work with.
No, that's actually really good and interesting to hear because, yeah, I mean, which is great because one certainly wouldn't think of, right? Large company like IBM would think about, let's put together a portfolio best of breed, right? Because IBM can't do everything and certainly startups can't do everything. And that's
Right.
interesting
And
that
the
you
way
guys have
I
approached.
see it is, right, we have Power AI, which is sort of the software distribution, the developer tools, the productivity tools. On top of that, I almost see a marketplace of solutions,
Yeah,
right? Marketplace applications. And that marketplace might be my solutions, my internal IBM solution, or it may be partner solutions,
yeah,
right? Because we don't have domain expertise in everything,
yeah.
right? That's number one. Number two, we don't have all the data, right?
Mm,
Recall our discussion in the beginning, right? To build a solution, you need to have the data,
yeah,
very high quality data.
yeah,
So we are definitely trying to build a marketplace and a route to market for many solutions into the customer, and that's what customers are looking for too. They'll build some of their own, they will buy a lot, and they will, you know, if you're an enterprise, you're just trying to solve a problem which enhances your revenue, right? Or enhances your customer's experience. So how you get there, whether you build it or you buy it, is typically, not, customers are open to that discussion.
yeah, yeah. I mean, especially if IBM, sort of being a trusted vendor and a partner, could aggregate and say that like all these stuff are pre-integrated and they work well. You don't have to do the systems integration. This is sort of the best of breed. I think that's very compelling. The trust is there, right? And whereas the trust may not be there with a new company or someone who's certainly not the heft of IBM.
Yeah, I think trust is one issue. Reaching the customer is another issue,
Yeah,
right? I mean, the market channel is actually even harder in many
yeah.
cases, right?
Yeah. No, this is awesome. Hey, Sumit, we can't thank you enough for you being generous with your time. I will follow up in a separate email to you with some of the things to so that we can get the links and repost it back to our group and a few other groups as well. I mean, this has been great, and we'd love to have you back again in the future as things develop. And thank you.
Oh, I'm happy to be here. Thank you so much for the opportunity. And if anyone has questions, please. I'm on the group now, so if you have questions, post a question. You can find me on LinkedIn and connect with me. I'm happy to answer more questions. Thank you.
That's so awesome. Thanks so much.
Thank
All
you.
right, bye
Bye.
guys.